Hello and welcome to the 6th week of the course Introduction to Advanced Cognitive Processes. I am Ark Verma from IIT Kanpur, and we have been talking about various cognitive functions in this course till now. This week we will start talking about problem solving. Problem solving is one of the very complicated, it's one of the complicated cognitive activities that people do on a daily basis. And in some sense, a lot of times you do not appreciate, people do not really appreciate that what are the different mental processes, what are the different cognitive processes that are contributing to somebody successfully solving a particular problem. And those problems can be very simple, as to say for example choosing between two colors, or sometimes very difficult. Suppose for example if you have to solve a maze within a given particular time, or say for example you have to solve the Rubik's cube with a time boundation. Now, at this point in this course, and I will try and link this to the earlier course that I have also taken, Introduction to Basic Cognitive Processes, we have by now talked about most of the cognitive processes that kind of contribute and kind of help in building up approaches and help in building up strategies that people might use in problem solving. We have talked about attention, we have talked about perception, we have talked about memory, we have talked about biases. In this course even we have talked about language, concepts, knowledge, categories. So all of those things now you would need to invoke and understand how all of those component cognitive processes are contributing to people finally achieving goal states from say for example an initial state where a problem is stated. So I have already mentioned in the description now that I have been talking, I have already told you what you might expect from this week. So we will talk about how people approach problems, what are the different strategies that people might invoke to solve particular problems, what are the obstacles in solving problems, and what are the factors that might help, what are the strategies that might help people solve problems. So the whole week will be about problem solving, and we will have a short lecture on creativity as well, because creativity in the sense is also a very important aspect of solving problems. People who are creative solve problems in more efficient, ingenious ways as compared to ordinary people, or as opposed to people who are not rated highly creative. But again, both of them achieve the same goal state starting from an initial state. I have been mentioning goal and initial state multiple times. So I think this is a good time to already define what a problem is. So a problem basically is when there is an obstacle that you have to overcome and surpass in order to reach from an initial given state to a goal state. So the idea is somebody or in some sense you are given a particular statement, a statement of a problem, and the statement of the problem might define an initial state. Suppose for example somebody could give you an equation that solve for x plus y is equals to 5 and x minus y is equals to 2, something like that, and then you basically have to figure this out. Now again I just arbitrarily picked this up, but the idea is the statement of equations is your initial state, and this is what the given knowledge is, and you have to take particular steps to solve for the two variables. So the idea is how are you going to do it, how are you basically going to tell us the values of x and y starting from the two equations that are given. So and the obstacle is that you have to do some calculations, you have to change around equations a little bit, perform some computations, and only then you will reach. Simply, or say for example if you take this to a different domain, somebody could give you that okay, there is stuff in the kitchen, you have to go and make make tea for example, and come back with the tea. Now the idea is you go there, you have probably not really made tea earlier, but there are these components there, the ingredients are there, and you have to kind of combine them in a particular fashion to come up with tea. So there are steps that you will have to take. The initial state is where you have ingredients all separated, and the final state is that when you have a cup of tea. So how does one reach from this initial state to the goal state, and what are the obstacles that you really need to surpass or overcome? That is basically what problem solving involves. Now, there could be different kinds of problems that you would come across. So, there will be problems which are very well stated, which give you all of the information that is needed, which indicate in some sense what might be the most probable and most direct methods that you will take, most direct routes that you will take to solve these problems. And these problems generally will have a correct answer. So, if you spend enough time, if you spend correct amount of effort, you will eventually solve these problems if you are applying a particular kind of a method. There are also these problems, by the way, are referred to as well defined problems. The other kind of problems sometimes we come across in life, or probably a lot of times, is the ill defined problems. Now, ill defined problems do not really necessarily have a correct answer. What is good, what is bad, is there God in the world? Those kind of statements are rather ill defined problems. So, if you attempt to answer them, there is so much that is unsaid, there is so much that is assumed, or so much that you have to really work with. So, these kind of problems are can be referred to as ill defined problems. They do not really have a correct answer for that matter, and the path to their solution to really come up with a response is very difficult. It is almost unclear and sometimes impossible to really come up with a straightforward solution to such problems. But you will see that people deal with both kinds of problems on a daily basis, and they kind of work around their ways to probable solutions, sometimes correct solutions, sometimes incorrect solutions. So, what we will try and do in this week is to see how people are actually achieving these goals. Now, one of the things is when you are approaching a problem, what is the first thing you would need to do? The first thing that you need to do generally is to try and understand the problem first. So, the point is that you will not really be able to solve any problem unless you understand what the problem is trying to say. A lot of times we tell students that even before you start attempting to answer particular questions in your tests or exams, you should spend a good amount of time reading the questions first. Unless you understand what the question is actually asking you, there is no way that you are going to be able to give a correct or an effective answer. So, it is kind of, you can take this analogy back to solving problems in real life and all those different scenarios, is that you have to understand the problem at first. Now, let me elaborate a little bit about understanding. So, understanding basically means that you have already generated a mental representation of what the problem is based on whatever is given in the problem and whatever your previous experiences have been. Suppose, for example, somebody is giving you again, let me go to the tea thing. So, the problem is to make tea. Now, the idea is you have been given the ingredients, that is the given information. So, you have some tea, you have some tea leaves, you have some milk, you have some water, you have some sugar, and then your previous experience is there, that that these things have to be cooked and they have to be mixed in a particular order to finally make tea. So, you have to first understand what really needs to be done with the problem, and understanding basically means that you have that, you have created that kind of mental representation. Now, problem solving, as I was already saying in the introduction, is basically an activity, it is a complex mental activity that builds upon several other cognitive activities, things like attention, perception, memory, reasoning, decision making. All of those things kind of will contribute to how you are going to approach a particular problem. So, let us take a few examples. For example, attention is something very important. Attention, or you can kind of in a more common parlance way, you can call this as concentration. Attention or concentration is very important in somebody being able to understand a particular problem, because attention is limited. There are limited attentional resources, and you have to allocate them wisely. You have to allocate them in a efficient manner, so that you kind of are attending the most relevant aspects of the problem that is stated, and only then you will be able to move forward from step 0 to step 1. Step 0 is the initial state, step 1 is the first step you take towards a problem, towards solving this particular problem. And it has been shown that say for example, if you have competing thoughts, if you have particular kinds of distractions, your attention will be limited and you will not really be able to engage with the problem correctly. One of the studies done by Bransford and Stein in 1984 demonstrates this very well. They presented high school students with story problems, and these story problems were like algebra problems, and what was happening was that the students were asked to record whatever they were thinking in their heads, and they were supposed to write those things down while they attempted to solve the problem. So what happens is that the students basically are having thoughts like, oh no, this is a mathematical problem, I don't really like maths, those kind of things they have to completely jot down. Once they start attending to their thoughts, they're not really attending to the problem so much, and these thoughts kept coming on and on, these negative feelings kept coming on and on throughout the 5 minutes that were allocated for solving the problem, and these things particularly distracted the students' attention from the central task. Now what happens is, obviously eventually their solving of problems was less efficient, probably they made more errors, they committed, they took more time. So this is a good demonstration of the fact that if you're distracted, if you're not really concentrating, if your attention is not there on relevant aspects of the particular problem, you will not really be able to achieve the goal. That is one. The second is, again as a subset of attention, a very important aspect of solving problems is focusing on the appropriate sections of the problem, focusing on the problem in such a way that you already get a clue from the problem about how to start approaching it, how to start solving it. So researchers have found that effective problem solvers, people who are very good at solving problems, difficult problems, they read the description of the problem very carefully. I was already hinting to how students should approach question papers and stuff. So researchers, and there is research, Meyer and Higarty 1996 have shown that effective problem solvers do read the description of the problem very carefully. They spend and they allocate a good amount of time in reading whatever the problem is saying, paying attention to inconsistencies, paying attention to patterns, and this attention might contribute in them solving the problem. So that is very, very important. Now let us move further. One of the other aspects that I would like to talk to you about in general about problem solving is that the way the problem is stated. We've talked about the framing effect in an earlier lecture, that how a particular problem is worded kind of changes or impacts how people are going to react to it. Now the way something is represented, the way the problem is presented to you, or the way you represent the problem to yourself. You might be reading a very difficult equation, or you might be reading a very difficult passage of text, and in order to understand it, the way you can change, the way you can represent this thing to yourself, this problem to yourself, determines and has contributes a lot to your being able to solve a problem. So there is this importance of choosing an appropriate way to represent the problem. There is, and that is basically effective representation will allow you to organize the information rather efficiently, and for example, it will reduce the strain on things like working memory. You will not really need to maintain everything through rehearsal in your working memory. If you have organized something very well, suppose if you drawn a picture or something, all of that information is out there, and you just have to kind of put the pieces together and solve the problem. So effective representation would increase the likelihood of you being able to select a very useful and efficient strategy for encountering the problem. Now moving ahead, the representation of the problem, one of the important factors is that it must show, it must depict the essential clues, the essential information that is needed to solve a problem. That is what is an effective representation. Unless it does not, unless it really gives you that relationship, it is very difficult for you to solve and start approaching the problem. Let's talk about a few ways in which people represent problems. Suppose for example, in high school algebra, you would basically sometimes be given word problems, and word problems will be something like, say for example, Ram is twice as old as Shyam and Rajesh is older than both of them combined by 6 years, and then you have been given Rajesh's age is 36 years old. You can just kind of spend a minute over it and come up with the equation which says x plus 2x is plus 6 is equals to 36, and you immediately get to the in a couple of steps you already get that, okay, x is equals to 10, so Ram is basically 10 years old, Shyam is probably 20 years old, and combine both of them at 6 is Rajesh's age, which is 36. Now the idea is, in words a lot of times people would struggle figuring out, and I'll talk about how people struggle with statements in a bit, but the good way of doing it is you just write an equation, you have all three ages, and then it's very easy to perform mathematical computations and figure out the age. So this is one example that people might use different kinds of ways to represent problems which will help them to solve. Now a major challenge here, a major challenge that problem solvers often commit is that they commit errors when trying to convert from words to abstract symbols. These kind of algebraic problems, the word problems that people solve in standards, I think 3rd, 4th, 5th and 6th. The problem in really eventually solving it is basically that a lot of times people make errors in translating the words to the equations. So Schoenfeld basically showed this, and Schoenfeld showed this in 1982. He was describing how calculus students were, when they were asked to rephrase simple algebraic problem statements, and they were basically asked that you just make it more understandable. It was observed that about 10% of the students' rephrasings, how they were actually rephrasing the statement, included information that directly contradicted the input. So whatever was actually given in the problem statement, when these people rephrased those problems, they kind of rephrased it in such a way that it kind of meant opposite to what the original problem was. And 20% of the rephrasings basically included really confusing or unintelligible information. So the idea is when they are converting the word problem into their own representations, they are kind of missing out on important information A, and in some sense they are kind of putting it together in such a way that it is almost impossible to solve it. Now this is something very important. The aspect of verbal intelligence, the aspect of understanding language also comes in here, and it kind of seeps in. That's why I was saying that problem solving per se has a lot of components to it. Now another common problem, just something that is linked to what we are talking about, is in converting sentences to abstract symbols, is that sometimes what the problem solvers may do is they might oversimplify the sentence, and in that oversimplification they misrepresent the information. So Meyer and Hegarty in 1996 they did this, and they were asking college students to read a series of algebra word problems, and then they were asked to recall them later. Now it was seen that a lot of times students misrepresented things like relational statements, which would have been very important to solve those problems. An example is, suppose the statement is that the engine's rate in still water is 12 miles per hour more than the rate of the current, and a lot of students just remembered that the engine's rate in still water is 12 miles per hour. So if you kind of miss out on the fact that it is 12 miles per hour more than the rate of current, you're missing out on something very important that actually might have been used to solve this. So that is something, that's just an example, a demonstration of how people might commit mistakes in changing or converting representations. Another way of representing problems might be using matrices. So one can solve problems effectively by sometimes building up just boxes and matrices. Say for example, if you were reading signal detection theory, detecting presence and absence of signal. So there is a high possibility that the signal is present there and you will detect it. There is a high possibility that signal is not present there and you will say no, the signal is not there. But there are also possibilities the signal is there and you don't detect it. Also possibilities of that signal is not there, but you say a false yes. So in signal detection theory, how people do it, they just draw a 2 by 2 matrix and they said signal present, yes, no, detected, yes, no, and it's very easy. If you can just fill in those boxes, you will get what is the percentage of hits, what's the percentage of misses, and stuff like that. If there is a big text explaining that this is the pattern of performance, you can just put that in the 2 by 2 matrix, and it will tell you what the pattern of performance of the participants are. And that's a good way to understand a particular problem as well. So matrices are very useful. I mean, in science engineering, various cases, matrices are very important to actually look at, and they help understand and simplify a representation of problems to a great extent. Another way that is again a very common way of people representing problems is by virtue of diagrams. Now diagrams are very useful when you want to put together a description together. Say for example, Novick and Morse basically in 2000 they asked students to construct in the origami objects, suppose say for example building a paper crow or a miniature piano or something like that, and they were supposed to do it using folded paper. And there were two kinds of people who were doing these experiments. One group basically received only a verbal description, and the other group basically received a verbal description and a step-by-step diagram as to how this is done. So for example, if you if you've sometimes bought some electronic appliances which need assembly or some kind of, we used to have in school SUPW kind of things, where you have a step by step demonstration of now fold this, then this is there, then now fold this one, and then this is how it's going to appear. So students who are actually receiving both the verbal description and a step by step diagram of how to go about it were actually much more accurate and efficient than people who just received the verbal description. Also, another very important thing, interesting thing about diagrams is that diagrams can be useful when somebody wants to represent a large amount of information in just one say. I was giving example of matrices. Say for example, here if borrowed a figure from Matlin's book on cognition, this is basically a representation of the different categories of items. Say for example, you will see animals, and then there are birds, and there are two kinds of birds, water birds and songbirds, and then there are mammals, there's horses and dogs and cats. So things like that, all of those things are organized in a particular. So with using this diagram, you can already understand what are the kind of hierarchy that is existing in these set of objects. So diagrams are also a very efficient way of representing large information that can be understood and that can be used to solve particular kinds of problems. Diagrams are also very helpful in representing complicated information in a clear and concrete form, so that you have more mental space. Suppose for example, you are spending half of your effort in just, or half of your working memory in just maintaining that thing. If you just draw it out, sometimes people do it when they are preparing or studying for exams. They sometimes would just draw it out in a particular way, so that just you see the figure and you realize the entire concept. So these things are very important, and they contribute a lot in people's problem solving efforts. Also, it has been shown that students can really master these aids, these different kinds of representations with relatively little effort. And Novick and colleagues, they did this in 1999, and what they did was they provided students with a brief training session on matrices and hierarchical diagrams. And after this training session, they actually tested the students on different kinds of problems, and they actually found that students who had attended this training session were much more skilled now in choosing the most appropriate method for representing a variety of problems. So already some training on this front, and for students who are watching this can actually practice this a little bit, and this will help you in understanding complicated problems, and obviously help you do much better in the studies part. So this is again, so finally I'll just kind of try and sum up the diagram thing, that diagrams can also provide additional advantages. For example, they would very simply just attract people's eye movement. If there is a lot of times we see presentations, if there is a very nice presentation with so many diagrams and figures, they would automatically attract your eye movements, they will automatically attract attention to relevant areas of the diagram, and in that sense they are more memorizable, and they are more easy to grasp, and in that sense, because they are easy to grasp, people will be able to use them and solve problems more efficiently. So that is all about these things, diagrams. Finally, one of the another things that is very important is figures, visual images, and it has been shown that people have been consistently using visual images to solve particular kinds of problems. People have found that visual images are very helpful in solving problems. There is a demonstration from this book, is the Buddhist monk problem, and I'll just read this out to you a little bit. So the Buddhist monk problem is very simple. It's very it's rather similar to the goat problem that we have in India. The goat has to cross the rivers, and there is a there's a goat and there is a crocodile. This one is also very similar. So the Buddhist monk problem is that exactly at sunrise one morning, a Buddhist monk set out to climb a tall mountain. The narrow path was not more than a foot or two wide, and it wound around the mountain to a beautiful glittering temple at the mountain peak. So the monk wanted to reach the temple, and at early sunrise the monk starts approaching the mountain. The monk climbs the path at varying rates of speed. He stopped at particular times to eat whatever food he has got with himself, and he reaches the temple just before the sunset. At the temple he fasted and meditated, stayed there for several days, and then he kind of began his journey along the same path, again starting at sunrise and walking as earlier with various and many stops. Now what the idea is, the question here is that you have to prove that there must be a spot along the path coming back and going up, that the monk will pass on both trips at exactly the same time of the day. So this is what the problem is, and you can kind of spend a minute or two, pause this, think how you will solve this problem. But if I have to kind of give you the solution or tell you an effective way of solving this, is something like this. So if you kind of assume that the start is almost happening at the same time, and you kind of vary in the factor in the various speeds and stops, etc., there must be around the half day mark that the person is going to cross the same kind of thing, because you're assuming a lot of consistencies in this whole thing. So if you look at the figure, you are easily able to grasp the solution of the problem, and this is just one example. There are so many other examples where use of visual images is encouraged, and visual images help you figure out problems much in the way as diagrams do. So visual image can, in that sense, help us escape from the boundaries of traditional concrete or verbal representations. And people who have good visual imagery skills also have an advantage that problem solving requires, because if certain kinds of problem solving requires to make certain figures, if you have a good mental imagery, you can actually use that to immediately draw a figure or immediately think of a visual scenario where you will be able to solve that problem more effectively. So this is about the various ways of representing problems and what problem solving is essential. I'll very quickly talk to you about a very interesting approach to understanding how problems are solved, and this is basically about the importance of context. Where are you solving that problem? What is the scenario? What is the setting? What is the place? What is the where is what kind of task you are doing? And those kind of attention to these kind of details also contribute a lot in somebody being able to solve a problem. Let us talk about this a little bit. So many psychologists and educators have emphasized things like situated cognition. Situated cognition is our ability to solve a problem is in fact tied to the specific context in which we have learned to solve that problem. Suppose, for example, you have learned to do any particular activity in a very specified set. Suppose, for example, you have learned do a particular task, let us say draw, in a classroom. Or suppose a lot of times what happens is students learn in sciences and engineering, students learn how different kinds of engines work, or how different kind of mechanics of materials work in their classes, in the engineering classrooms. But a lot of times you will see is they are not able to apply those things outside when they go inside the real world. You have to just take the concept from the classroom and take it outside and try and apply it to solve the problem at hand. Okay, and there are very ingenious things. Suppose, for example, I am remembering that there was this movie, I think 3 Idiots, and therein the person who is playing the main lead is using a lot of the things that he is learning in class in real life scenarios. So the idea is you can take whatever you are learning is inside the class outside as well. The fact is that a lot of times people are not able to do it. A lot of times our ability to perform particular tasks, to achieve particular kinds of goals is tied to the context. It is tied to where you have learned this. And there are a lot of examples. So supporters have argued that abstract intelligence test often fails to really reveal on how competent a person would be in solving the problem in real life setting. So for example, there is a student who does very well in the class, he does very well in all the assignments and tests, etc. But as soon as you take the student out in a real life setting, things like civil engineering or architecture and those kind of things, students kind of falter a bit and they hesitate, and there are problems of really converting this. So as compared to a particular student who has not really done very well in the class in assignments and so much, but very quickly he can apply all of that what was learned in a real life scenario. So these kind of examples are there. And there has been a lot of research on situated cognition, and that research demonstrates that ordinary people frequently succeed in figuring out which brand of a particular product is cheaper in a grocery store, even though they would fail to understand the same problem if it is asked in mathematical test. Certain kinds of decision making scenarios. If you remember what we were talking about earlier in the earlier lectures about the Kulwane tribe, how people are actually solving Watson's card sorting problem, 4-card test. when they were given an abstract thing, there was problems in solving it, but when they were given a real life scenario, immigration things or beer drinking problem, they could actually solve it much more easily. So those are things you can actually link to the description that's going on here. Now, the traditional cognitive approach to thinking emphasizes the fact that the processes that take place inside an individual person's head, while the situated cognition approach argues that the latter approach is too simplistic. So the cognitive approach will basically say that everything is just happening in the person's head, and the situation, the external scenario does not really matter. But the situated cognition approach, or slash the embodied cognition approach in some sense, says that it is the external environment also that contributes to somebody being able to perform a particular task. After all, say for example, in real life, our cognitive processes take advantages of the rich environment. If you remember, when we were talking about perception, there is a lot of cues to solving inconsistencies or degraded inputs that you take from the context, that you take from the environment. So in real life, we often interact with people who provide information and help us clarify our cognitive process. They help us map the abstract world to the real world, and that is what helps us achieve good solutions to problems sometimes. All of these factors help us become more competent in understanding and solving different kinds of problems. So the situation cognition perspective has really important implications for education. It suggests that children should have experience in solving authentic math problems that they are likely to encounter in a school setting. So whatever they are really learning in school using abstract things, they should be actually also taught to solve real life problems with real examples, and they should be given assignments that help them to apply these abstract principles that they learn in real life scenarios. The situated cognition perspective also suggests that college students can learn effectively during internships and other practical settings much more. Nowadays, there is a lot of emphasis on applied education and stuff. So that's a very good approach, because it kind of tests how much you are going to be able to apply whatever you are learning in class to real life scenarios. So that's why internships are a very good idea in that sense. And the situation and one of the advantages, one of the things with the situated cognition approach is that these kind of approaches lend us more ecological validity. Now, ecological validity is how much you can generalize a particular scenario to other different settings. So a study of children's mathematical skills in selling candy would have had greater validity than the study of children on just doing some basic algebra. So if you kind of tell children that you have 4 candies and I take 2 away from you, then the answer will be probably faster, and I am talking about younger kids, than if you just ask them 4 minus 2 is what. So these kind of approaches, this is what basically the situated cognition principle kind of emphasizes. Now finally, an important principle of the situated cognition approach is that people learn skills within the context of a specific situation. Suppose for example a grocery store where the kid is selling candy or stuff. As a consequence, there is a good possibility that they may fail to transfer these skills and use them effectively in other situations, such as a standardized maths test or something like that. So obviously, for educators and employers, etc., a good strategy could be to devise certain scenarios where things are tested in such a way that there is opportunity to apply whatever has been learned in the abstract form in real life settings, and then also the evaluation should not only be on the abstract test, it should also be on the practical application aspects of it. So that is I think all from my side about situated cognition and a basic introduction of what problem solving will be about. We will move to the next lecture and talk about more aspects of problem solving. Thank you.